Assalamualaikum warahmatullahi wabarakatuh. My name is Rifki Fadila Akbar, NRP 29 from Diploma 4A Telecommunication Engineering class of 2017. I will to present my progress on my final project, the Priority Based Testing System or PBITS application with K-means algorithm for clusterization of COVID-19 patient types. My first supervisor is Mrs. Hania Mahmuda and my second supervisor is Mrs. Ari Wijayanti.
Here's the illustration of my final project. My final project consists of K-means model, application, and API service. How it works is when the user inputting their data, the model using API service processes it, and the application shows the result from the model's cluster prediction. Here's the overall block diagram of this final project for the illustration as I mentioned before. And here's the block diagram of the first final project progress. It's the process of the K-means model making. It consists of several processes such as raw data, and then the raw data are pre-processed before processing process. For the K-means, I use some clusterization scenario using some alternate version of the dataset. And then the fourth process is to making the K-means model. And then the last step is to validate and test each scenario's model. Before I explain about the process of K-means, I will briefly explain about the K-means algorithm. Basically, it consists of two major steps, the cluster assignment and move centroid step. Firstly, we pick some number of cluster we want to give to the dataset, and then we calculate its sample distance to the cluster centroid or the center coordinates of the cluster. And then the cluster member is the sample that the closest distance to the cluster centroid using Euclidean distance. That's the cluster assignment step. And then we can update the centroid position based on the average distance of each cluster member or the mean. That's the move centroid step. And then we do it until there is no more moving centroid. The problem of k-means are we cannot simply pick the k values. So for that, we can use some method to decide to pick the number of k. And then raw data. Raw data process consists of checking our exploratory data analysis, data cleansing, merging, and tagging. And then I am using open source dataset from Kaggle. The dataset consists of 6 major parameters such as country, age, symptom, experience, severity, and contact. Each parameter has its own columns. It has 27 columns and 300,000 records. And then we go into the cleansing, merging, and tidying process. For cleansing consists of dropping transgender and country. The merging process is used to merge severity column into one column and rank them from none to severe condition. Thus, we have 22 columns with 200,000 row because of the cleansing, merging, and tidying process. And then we can go to the pre-processing. The pre-processing consists of looking at the spread of the data, calculate the parameter correlation, and doing correlation analysis. The data spread, we can check each column member by plotting and looking by its number. And then we can check its mean and standard deviation. And this step is needed to check if there is any outlier and how the data is spread across the columns. And then we can look at the correlation of each column to know the most influential parameters. And then we go into the k-mean process. It consists of making each scenario dataset and then doing calculation for finding the optimum number of k. After that, the k is used to train each scenario data for clusterization process. The first scenario, this is the dataset. In this presentation, I will show you just two scenarios to compare. The first scenario is using the dataset from the pre-processing step before without making any alteration. We can look up the k values by doing some method, and it shows that it tells us that the optimum k values of first scenario is 6, and then we can do the k-mean process on using these 6 k values. After we train the data using 6 k values, we can look each cluster values. It shows that each cluster is not evenly spread. And we can check the centroid values too for checking each column centroid for each cluster. In this picture, I show you only 8 column. Actually, it has 22. And then we go into the second scenario. The second scenario is using only the biggest correlation columns. It consists of 14 columns. The dataset, the sample number is 200,000. And then we can pick the k values by using three methods. The second scenario is showing good k optimum finding process, where in the elbow method, silhouette method, and the dp index is showing all 6k. Thus we can pick 6 number of k for second scenario. And then we can see that the cluster is evenly spread. It's really fine. And then we can check the centroid values too. Then we get into the testing or validation process. In this process, I used 60 sample data which I rank from A to F to indicate its severity and to validate each scenario. We can validate by how it's rightly or wrongly predict my test set. From using my test set, it can be seen that the first scenario is more showing good performance than the second scenario. Conclusion. From the first and second scenario, some method can be used to give a good number of k. The first scenario has uneven cluster spread but good new testing data prediction. And then second scenario has uneven cluster but not as good as the first scenario for new testing data prediction. And then good clusterization and testing performance can be used to decide what scenario will be used. And here are some of my references I use. Thank you for your attention. I hope we are always in a good condition. Wassalamualaikum warahmatullahi wabarakatuh.